All right, so the next exercise we're going to do is we're going to develop a sketch where a circle is moving again in the same way, but we're going to put all of those kind of specific elements that describe how it should move into a function. All right, so instead of just seeing our ball move, we're going to see it actually bounce. We'll call it a bounce, and we'll put the behavior of that bounce into a function. Okay, so what's a function? Functions are simply blocks of code that you can call each time you wish to execute some functionality. Right? They're a means of taking the parts of our program and separating them into modular pieces. Right, now we haven't really used the function yet in this course, but we're going to, in this exercise, to see how we can use this as a way to structure or organize our program in a particular way. So, what are functions like a little bit more technically? Well, they require inputs, which we'll call arguments, and they may or may not have outputs, or what are sometimes called returns. Notice that when we use the global setup, we type void setup. Now, there's a question about this in the last course we offered on the introduction to processing, and this is a good moment to bring this back up. By saying void, you're saying that you're not going to return anything, and therefore the setup isn't required to return any type of value or anything like that. So void is a way to clear the return. You don't have to actually return anything. All right. So here again is a kind of plain language description of how you set up your function. You have to specify a return type, or none being void. Specify the function name. If there are any arguments, you have to specify both the type as well as the name of that variable for as many arguments as you have. Within that function, you're going to execute some sort of statement or do some action. And then if you are returning anything as the result of the function, you have to specify what that return will be. Okay, so what do functions do? They help us organize our program clearly. They're also efficient, so we don't have to type things multiple times. Anytime we want something to bounce, we'll just use our bounce function. It also promotes modularity, which means that we can take these little portions of our program and use them in other scenarios. Whenever we want to have something bounce off the edge of our screen, we can use this function. And again, that also promotes reusability in a different context. All right, so what is modularity exactly? Well, it's the compartmentalization and interrelation of the parts of a program. All right, so we looked at the way that a program is structured generally inside of processing, the global variables, the global setup, and the global draw. That's one way you can think about modularity, right? Is how things are compartmentalized. Same works with functions, right? Setup and draw are actually functions that are native to processing. All right, so let's make our circle that we had before work with a function that says bounce whenever you meet the edge of the screen. Okay, so this is going to be our second file, O2, circle with simple functions. It's my working version. All right, and really what we're going to be doing here, let's revise our topics. Up at the top, we're going to be working with functions. Right. Nothing much changes about the majority of what we have here, except for at the very end, we need to go ahead and use or specify what our function is going to be. And really the function is going to take all of this part of the code and move it into another module within the structure of our program. So down at the bottom, this is typically where you would do this. We're going to reserve an area for any kind of functions. All right? Now, the first one we want to do is create our bounce function. So let's set that up. It doesn't have to return anything at this point. So we're going to say that we'll start by actually kind of constructing the outer layer of the function by saying void bounce, open and close parentheses because we don't have any arguments, open curly brackets, and close curly brackets. All right, so what's going to happen in here? Well, we shouldn't really even need to pseudocode this because we're going to take this portion of our program, the conditional action for bouncing. I'm going to do Control X for cut. Control X, paste. All right, this is the conditional action for bouncing. Control T, and now that looks correct. Okay, so if I were to hit play or run now, we'll see that our circle moves off the screen again. Right? Now, we've created a function called bounce, but we actually haven't used it yet. Remember back and we're looking at the graphical representation of the anatomy of our sketch. We have global setup, global draw, etc. But this defines the scope of what's going to happen within the draw action, right? Within the draw function, these actions are going to happen, and we haven't actually said to bounce because this is external to that bit of scope, right? This block of code. So what we need to do is inside of our draw, we need to call to the bounce function. So all we're going to do is type in bounce, that's the name of our function, open and close parentheses, and semicolon. Control T, that will clean up our formatting. I'll hit run. Now my circle should bounce. Perfect. All right. So now we have a bouncing ball. Now, since we're comfortable with using functions, let's go ahead and use another one. Right? Let's say that instead of just bouncing in a kind of environment where there's no gravity, let's go ahead and make it a little bit more specific so that it looks like it's falling under gravity. A way to think about that is that it has drag to it, right? So let's take another, let's move down below our bounce function and add in void drag. Open curlies, close curlies. All right, so what we're going to do is use this function to increase the speed values. And this is, of course, going to be used every frame. All right, so with drag, all we really want to do is that we're going to increase the speed values by a value each frame. So we'll start by doing this manually or kind of hard-coded. So we'll say x speed plus equals 2.0. Y speed plus equals 2.0. Actually, this should, x speed should be 0.0. All right, so 0.0 drag in the x, 2 drag in the y. All right. If we also use that here in the global draw, right, our drag function's being called, and my drag value is too high, so let's do 0.2. Now we can see that the circle bounces as if it's falling under gravity of its own weight. That's because each frame we're adding a value to the speed so that the behavior of the bounce is changed a little bit. All right, now my circle went past the edge of my screen, so this brings up another good question, right? For our bounce function, if we are near the edge of our screen and it tells us before we bounce, we're near the edge of our screen, we update the position in Y, and it goes to a value where we are less than, sorry, the position value is greater than height minus radius, so essentially 380 in this condition. And if we reverse the speed, it's not fast enough to be able to make sure that it stays above this maximum Y direction. So what we're going to do is also add in a little kind of insurance program here, where we're going to say that if this condition happens, right, if the Y pause, we'll just repeat the same conditional statement here. If it's greater than height minus radius, we'll set the y position equal to height minus radius, height minus rad, right? And we'll copy that down here also, so that if it is in this condition, y pos less than rad, we'll ensure that it equals rad. And if we've got that set up, let's just go ahead and do that for x as well, right? So internal to the if statement here, right, we're saying if either of these conditions are met, do this, but specifically if it's this one, do this action versus that that condition, that action. So we have to change this to width, xpos, 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 save and run, and now no matter what happens, my circle should never go past my threshold here at the maximum y direction. All right, so if you have any questions, go ahead and drop in the window. This is going to be the end of our second exercise. All right, it looks like we're all clear, ready to move on to the next exercise. So with the simple functions, again, what we're doing is just encapsulating a portion of our program into a function for easy use, right? And clarity of organization. All right, so the next thing we're going to do is really get into what objects are and how they're specifically useful within processing and within the idea of developing some dynamic behavior.